All right, number 1 through, now we're going to try to get through 71. This is 5.1, okay? So, for Precal, and it should be MTS Precal, and we'll HW 5.1, right? And if you put that at the top of your page, you'll know where to go to see it on the YouTube. Okay? All right. So if I want to do this square root, and I know some of us do a little different. They take out squares instead of primes. But the reason I take out primes is because then when I go to cubes, I don't have to try to take out cubes. I go to the 5th power, I don't have to take out a 5th root. I just take out groups of 5, groups of 3, groups of 2, whatever it's telling me. Does that make sense? You know? And that way, I'm always doing it the same way. I think I pushed record. Yep. Okay, so with 144, I know that that's 12. Right? Because 12 times 12 is 140. So if you're good, you're good. Right? How did we get there? Is like 144, break it down, 2 goes into 144. What is that? 72 times, and 2 goes into 72. What is that? 36. And then 2 is 18. And then 2 is 9, and 3, and 3. And then I take out the groups of, there's a pair, and there's a pair. So it's 2 times 2 times 3, which is 12. And that's how we do that problem. Okay? This is the root for all of these. Is that making sense? Okay? So, use what you know to figure out what you don't know. So on 16, the way I would do 16 is I would take 16 and I would break it down. 2 is 8, 2 is 4, 2 is 2, and 2 is 1, right? And it says groups of 3. Right? So right here it's telling me to grab groups of 3. So I'm going to grab triplets. And that's going to be 1, 2. Those 3 of them, here 2 of them change to 1. But with a cube root, right, 3 of them change to 1. And whatever doesn't get circled gets put into the cubic, into the cube root. And so what it equals is 2 cube roots of 2. Good? Wait for a second. Remember,
so how'd you get that?
It says without a calculator, because on the SBAC they're going to make you do it without a calculator.
So how'd you get that?
Which one?
3.
Okay.
Oh, okay. I didn't see it on the right. I didn't see it on the right. You just agree with me.
No, just saying. Okay. Next. Are we good? Do the next one real quick?
Next.
Okay, next. Number 5. So I'm going to do that in green. Okay? Or no, I already did green. Let's do it in purple. Right? Purple. Where's all the purple? Purple. Alright, number 5. So, first of all, let me kind of mix it up. This is weird. Now, I know 81 is squared to be 9, right? But I'm like, how do I want to deal with this? In my head, what I want to do is think of this as 10, hundreds, thousands, 10,000s, right? So right there, I have 10,000 on the bottom and 81 on the top. That's how I would do it. Okay? Okay? Right? And then I could go, well, that's kind of nasty. That doesn't break down. Oh yeah, it does. There's only 4 zeros, right? 4. Get it? I couldn't do it. There's only 4 zeros. There's only 4 zeros, right? So 4 zeros, what's half of 4? 2, right? So that would be right there. So basically, the square root of 10,000 would be 100. Does that make sense? So if I'm dealing with this down here, and I know I have the even amount of zeros, I can go, well, what's half of those zeros? Because this is by halves, right? This is 2. If it was in threes, it's a little different. That means you have to have this times this times this times this. You would have to break this 10,000 down if it were a cube root, right? But it's not that hard to break a 10,000 down. 10,000 is 2, that's 5,000. 2, that's 2,500. And 2, and you would just go down, and what you're going to end up with is 100. So probably 2 times 2.
Oh, shite.
Oh, so you're going to use 100, so you're going to break that down into 4, 8, and then,
You break both of these?
wouldn't it be 2 again? 2,500, and then 5, 5, 5, and 5.
725.
So that would be, what is that?
The 6
1,
and a half and 12.
2, 5,
Okay.
0, right? Are we going to end up with 2 more zeros? 2 more 2s? No, 1 more 2, I think. Right? Because this would be 25.
Yeah, 625.
So 625, and then that's going to be 5, 5, 5, and 5, right? So that's 125,
Why don't you pay for it?
then that's 25, and then that's 5, and that's 1.
Yeah, Venus Free.
Right? And what you're going to end up with is a pair, and a pair, and a pair, and a pair. So 2 times 2 times 5 times 5, which is 100. So you're going to end up with 100 on the bottom. Okay? And then, like I said, cut that in half. You still end up with 100. But then 81. And then you break down your 81. Well, in this case, it's going to be a 3. That's what, 27? 3. And it's 9, 3, and 3. So you're going to have a pair and a pair. So that's going to be 3 times 3 is 9. So 9 100ths. And how would we write that in a decimal form?
0.09.
0.09, 9 100ths. You see how you do that without a calculator?
Yeah.
Okay. Does that make sense?
Yeah.
It's not that bad. Break it down. Okay? Now let's do this one with the same ideology. Same ideology. Okay? This is tenths, 100ths, 1,000ths. Right? So now we have this a little bit different. This is going to be 8 over 1,000. Cube rooted. So I need to break down the 1,000. Okay? So 2 goes into 1,000 500 times. 2 goes into 500 250 times. 2 goes into 250 125 times. 5 goes into 125 25 times. 5 goes into 25 5 times. And 5 goes into that. Now, what did we get? Take out our triples. So that's a 2. And our triples. And that's a 5. So what we're left with on the bottom is 2 times 5, which is 10. Right? And then what's left on the top? Well, we're taking the 8. We're going to break down the 8. That's 2, that's 2, and that's 2. We're taking out the triples, so that's 2 tenths. So how could I write that as a decimal?
210.2.
0.2. Okay? Or like that. Okay?
Is that cube rooted 0.2 or did 0.2?
We took out the cube, so we take out 1, 2 for the 3, so now it's no longer, we got rid of the cube root. How are we doing? Now, this one I'm going to do a little easier. This is really, I'm going to do this a little differently. This is really 0.05 raised to the 6 raised to the 1/2. So what's half of 6?
3.
3. So that's 0.05 to the 3rd. So what is 5 times 5 times 5?
125.
125.
Why did that?
1, 2, pi, right? But how many decimal places are there?
2.
2, right? So that means 3 times 2 is 6. So it's actually going to be 125 and then 1, 2, 3, 4, 5, 6 and then fill in the cups. 1, 2, 3. So we're going to end up with 0.000125. Does that make sense?
Coach?
Buddy? We good? Or did I go too fast? I know if I'm going too fast for you, then I'm going to go.
Wait, yeah.
Is
Yeah. Coach isn't here next week?
Coach is in here 7th period.
So, do you know where he is 5th period?
He should be in Paulus for K18.
You say Paulus? Oh, my line.
He might be with Todd though. I don't know.
Fuck Hudson.
Bro, I worked hard today, man. I was
Square root.
I was on paper.
Yeah, because remember there's a hidden 2 right here, right? And that's the same as a 1/2 power. And then what I did is by throwing it into the power form, I was able to say, okay, that's 1/2 of 6. So I was able to just reduce that down instead of writing them out and then, you know what I mean? It could be really big and then breaking it down. I mean, that would just be the hard way of doing it. I would way rather deal with the fractional exponents, deal with the exponents first, then deal with what's left. Does that make sense?
Yeah. Why did you just point 0? Why did you move the
0.05? Or
when you did from 1 to 2.
oh, like this? Because when I say 0.05 times 0.05, right?
Oh, yes.
Then I'm going to move those decimals, that make 4 of them, right? But then when I multiply by another 0.25, then it's going to do another 2 places. So what I did is just multiply the 5s, right? Get the 125, and then multiply how many decimal places I have, which is 1, 2, 3, 4, 5, 6. So now I'm going to move it over 6 places. And that's why I came up with the 1, 2, 3, 4, 5, 6. Does that make sense? So 6 decimal places because of these 2, and these 2, and these 2. Right?
And what do you do with that half?
So the half came from the square root. A square root is really a power of 1/2. So all I did was change this into this, right? And then when I'm taking a power of a power, we multiply exponents, right? So then 1/2 times 6 gives me 3.
Yeah.
Cool. Good? All right.